All right, so today we're going to be taking a deep dive into the world of secure coding,
Okay.
specifically in Java.
All right.
Um, and we're going to be doing this by going really deep into this academic PDF that we have.
Sounds good.
It's pretty dense, but hopefully we can
Oh,
pull out some really good information to help you all build applications
yeah.
that are as secure as Fort Knox,
Yeah,
without all the gold bars, of course.
absolutely. And I think this PDF is going to give us a lot of great information, and I'm excited to go through it.
Yeah, for sure. So let's get started. This first section is all about secure by design.
Okay.
What does that even mean? Like, are we talking about drawing blueprints for a digital fortress or something?
Well, I think that's actually a pretty good analogy.
Okay.
When we talk about secure by design, we're talking about thinking about security from the very beginning
Right.
of the software development process. We want to make sure that security is baked into the application's DNA, so to speak.
So it's not just about adding security features later on. It's about making security a core part of the entire design process.
Exactly. You want to lay a solid foundation from the start, just like you would with a real fortress.
Got it. So where do we even begin with this secure by design approach? What's the first principle we should be thinking about?
Well, I think the most crucial one is probably what the PDF refers to as establishing trust boundaries.
Trust boundaries, okay? I'm intrigued. Tell me more.
So you have to define very clear lines within your system, separating the areas that you absolutely trust from those that require, more scrutiny. You wouldn't want to treat everything with the same level of trust.
So it's like drawing a line in the sand saying, okay, you can come this far, but no further.
Exactly. Think of it like this. Let's say you've got this super secure application server, lockdown type.
Okay.
And then you decide to add an email server to your system.
Right.
Email servers, by their very nature, they talk to the outside world, which makes them a bit more vulnerable. You wouldn't want to treat that email server with the same level of trust as your core application server.
Definitely not. I mean, my spam folder is a testament to the dangers of trusting emails blindly.
Exactly. That's why you'd establish a trust boundary around that email server, maybe even put it in a DMZ, a demilitarized zone, a sort of buffer zone,
Right.
to isolate it from your more sensitive systems.
Like a security checkpoint before you can get to the crown jewels.
Yeah.
So how do we actually apply this trust boundary concept to, the code we write?
Well, think about input validation, for example. Even if data is coming from a source you generally trust, you still need to validate it, make sure it's clean before letting it interact with your core application data. It's like checking the ID of everyone entering the fortress, even if they look familiar.
Okay, I'm starting to see how this works. So when I'm designing my next job application, I should be thinking about the different components and data flows
Right.
and asking myself, where do I need to draw those trust boundaries?
Exactly. It's all about understanding where the risks are and then putting in the right security measures to mitigate those risks.
Got it. So trust boundaries help us think about security in a more, I guess you could say, structured and organized way.
Hmm.
What's the next principle we should be aware of?
This one's a good one. It's all about efficiency and practicality. Don't reinvent the wheel.
I love that.
Yeah.
I'm all about working smarter, not harder. How does that apply to secure coding, though?
Well, it's pretty simple. Use existing code and libraries and frameworks, especially for things like cryptography. You don't need to spend hours trying to
No.
write your own cryptography algorithms from scratch when there are already tons of well-tested solutions out there.
So it's like using prefabricated building blocks for our fortress instead of, trying to carve each stone from scratch.
Exactly. Think about all those certified cryptography libraries, like the ones on the FIPS 140 list,
Right.
Those have been rigorously voted. They meet really strict security standards. Using them saves you a ton of time, makes your code less complex,
Yeah.
and it's built on a solid foundation.
And this applies to more than just cryptography, right?
Oh, absolutely. Look at Java frameworks like Spring MVC or Grails. They come with all these built-in security features
Right.
that handle things like input validation, SQL injection prevention, other common vulnerabilities. You get a huge head start on security, and then
Yeah.
you can just focus on the stuff that's unique to your application.
So it's like getting a security starter kit along with your development tools.
Yeah.
I like it. What's next on the list of secure by design principles?
Okay, so this one is economy of mechanism, or as some people call it, the KISS principle. Keep it simple, stupid.
Hey now, I'm no fool,
Yeah.
but I definitely appreciate simplicity.
Well, that's good because complexity can be a real nightmare when it comes to security. The more intricate your code is,
Yeah,
the
yeah.
harder it is to test thoroughly, the more chances there are for bugs to hide.
Right.
and the more difficult it becomes to maintain and update it securely.
It's like building a fortress with so many secret passages and hidden chambers that you can't even keep track of them all.
Exactly. Remember that heartbleed bug in OpenSSL?
Yeah.
Classic example of complexity gone wrong. It was a tiny vulnerability in a widely used cryptography library, but it had a massive impact because it had exposed sensitive data
Oh, yeah.
on countless websites.
Right.
So you see, keeping things simple actually makes your applications more secure. It's a win-win.
I'm all about those win-wins. All right, what's next?
Okay, so this one is all about being cautious and skeptical. Trust reluctance. It means designing your system so that it doesn't grant privileges blindly.
So a healthy dose of paranoia when it comes to security. I like it.
Yeah, you could say that. The idea is that you should never grant privileges based on a single condition.
Okay.
You need to have multiple checks and balances
Sure.
before giving access to anything sensitive.
Like needing 2 keys to open a vault.
Precisely. A classic example is the old UNIX privilege model. It was very much an all-or-nothing approach. If you had root privileges,
Right.
you were all-powerful. But if you didn't, you were severely limited. And that actually led to some serious security issues.
Like having a king and the peasants with no middle ground.
Exactly. One specific example, binding to low-numbered ports that required root access.
Okay.
So the SendMail program, the program that sends email, that runs on port 25,
Right.
well, it had to run as root.
Oh, wow.
And any vulnerability in SendMail could potentially give an attacker complete control over the entire system.
Yikes, that doesn't sound good. So how does trust reluctance help solve this problem?
Well, you compartmentalize those privileges. You only
Sure.
grant access to specific things based on very specific needs,
Course.
rather than this sort of blanket all-or-nothing approach. Think of it like a modern distributed system where
Right.
different components run on different servers with varying levels of access. So even if an attacker breaches one part of the system,
Right.
the damage is limited.
So it's like having multiple layers of security, each with its own checks and balances.
Exactly. Now, when you apply this to your Java code, it means being very deliberate about what each part of your code can access and under what conditions. Always ask yourself, does this piece of code really need this level of access?
Right. Minimize those privileges wherever possible.
Exactly.
Okay, so far we've covered trust boundaries, using existing secure code, keeping things simple, and being cautious with privileges.
Yeah.
What else is there?
Okay, this next one might seem a little counterintuitive at first, but it's really important. It's called open design.
Wait, open. Doesn't that make it easier for attackers to, like, figure out how our system works?
Well, that's a common misconception. Open design doesn't mean publishing all your source code for the world to see.
Good.
It just means acknowledging that security shouldn't rely on secrecy.
So it's not about hiding the blueprints. It's about making sure the fortress is strong enough, even if the design is known.
Precisely. The more eyes on your code,
Yeah.
the more likely it is that vulnerabilities will be spotted and fixed before they can be exploited. This is related to something called Kirchhoff's principle,
Sure.
which basically states that a crypto system should be secure even if everything about the system, except the key, is publicly known.
So security through transparency and open review.
Exactly. A good example is the GSM A51 encryption algorithm, the one they used in early mobile phones.
So?
They tried to keep it secret, proprietary, and you know what happened? It got cracked. Hiding the design didn't make it more secure. In fact, it probably made it less secure because it prevented that open scrutiny
Right.
by the security community.
So security by obscurity really is a myth. Transparency and collaboration are key.
Exactly. Now, in terms of applying this to your Java projects, one thing you can do is use well-documented libraries and frameworks that have been reviewed by the community.
Gotcha.
And if you're working on open source projects, encourage people to look at your code, provide feedback that can help identify security issues early on.
Okay, that makes sense. Now we still have a couple more secure by design principles to cover, right?
Yeah, we've got minimize the attack surface and secure the weakest link.
Okay, those sound pretty straightforward. Tell me more.
So minimize the attack surface is all about reducing the number of potential entry points that an attacker could exploit.
All right, make the target smaller, harder to hit. What about secure the weakest link?
Right, so secure the weakest link acknowledges that no system is going to be perfect, there will always be vulnerabilities, and attackers will always go for the easiest point of entry, so you got to figure out where those weak points are and make sure they're secure.
So it's about being realistic. Understanding that no fortress is totally impenetrable.
Right.
You just got to make those vulnerable areas as strong as possible.
Exactly. Think about this. Network printers. They're often overlooked from a security perspective, but they can be a real weak link. The PDF actually mentioned HP printers with JetDirect firmware,
Oh, yeah.
which has this little embedded web server for remote management.
So you can manage the printer from your computer. What's the security problem there?
Well, if there's a flaw in that web server's password handling, an attacker could get into the device.
Oh, wow.
They could steal data, disrupt printing, or even use the printer as a launching pad to attack other things on the network.
I never would have thought of a printer as a security risk. That's why I love doing these deep dives.
Yeah.
So any final thoughts on these last two secure by design principles?
Sure. So for minimizing your attack surface, think about things like reducing unnecessary dependencies, disabling unused features, and minimizing the amount of code that runs with high privileges.
Okay.
And then for securing the weakest link, one technique you can use is threat modeling.
Right.
You basically try to think like an attacker and identify potential vulnerabilities, and then you prioritize those vulnerabilities based on their potential impact. So you focus on fixing the things that would cause the most damage if exploited.
Okay, so it's all about prioritizing and focusing on the most critical areas. All right. That was a lot of really great information on secure by design. Can we do a quick recap before we move on?
Yeah, of course. So we talked about establishing trust boundaries. That means you got to define those clear boundaries within your system, separating areas you trust from those you don't,
Right.
and then apply appropriate security measures to each. Then there's don't reinvent the wheel.
Leverage those existing tools and libraries.
Exactly. And economy of mechanism. Keep those designs and security mechanisms simple and straightforward. Less complexity means fewer vulnerabilities.
Yeah.
And it makes it easier to test and maintain your code. Then we talked about trust reluctance. Always be cautious about granting privileges, require multiple checks and balances before you give access to anything sensitive. Open design, well, that's about acknowledging that security shouldn't depend on secrecy and embracing transparency and peer review to make your systems more robust. Then there was minimize the attack surface, which means reduce those potential entry points that an attacker could exploit.
Right.
And finally, secure the weakest link. You got to identify and prioritize the most vulnerable parts of your system and focus your security efforts on strengthening those weak points.
Wow. You managed to sum up all those principles in like a minute. That's impressive. All right, I'm ready for the next section. What's up next on our secure coding adventure?
Well, next, we're going to be talking about secure by default. So this is all about making sure that your application starts off in the most secure state possible.
Okay, so we're going to be laying down some serious security groundwork. I'm excited to learn more.
All right, let's do it.
All right, so we're moving on from secure by design, designing with security in mind,
Right.
to this concept of secure by default. What does that even mean?
Well, secure by default is all about setting up your application with the highest level of security right from the start.
Okay.
So it's like, you're equipping your fortress with all the defenses activated on day one instead of trying to add them later.
Okay, yeah, that makes sense.
Yeah.
So what's the first principle we should be thinking about in this, secure by default approach?
So the first principle is use least privilege.
Okay.
And that's all about being very stingy with access. You only grant users and programs
Okay.
the absolute bare minimum privileges they need to do their jobs.
So it's kind of like each guard in the fortress only gets a key to the specific areas that they need to patrol, right?
Yeah, exactly. You don't want to be giving everyone the master key, right?
Why not?
So for example, if you have a program that needs to read data from a database, it shouldn't have write access or delete access unless it absolutely needs it.
Right.
So by minimizing privileges, you limit the potential damage that an attacker could cause, even if they do manage to get in.
So less privilege equals less risk. I like it.
Yeah.
How do we apply this principle in a, real-world Java application?
Well, when you're thinking about user roles and permissions, don't just automatically give everyone admin access. Define specific roles with limited privileges and only assign those roles to users based on what they actually need to do.
Okay.
And then when you're writing code, be mindful of what privileges are needed for each operation. Don't execute code with elevated permissions if you don't have to.
So it's about being very deliberate and careful about who and what has access to which resources.
Exactly.
Okay, what's the next secure by default principle?
So the next principle is use default deny.
Okay.
And this principle means that by default,
Okay.
access should be denied unless it's explicitly granted. So it's like having a really strict bouncer at the door of your fortress, checking everyone's ID before letting them in.
Sounds pretty secure.
Yeah, so everything is denied unless it's specifically allowed.
Okay.
And by defaulting to denial, you create a much more robust security posture. If there's a mistake in your code or some kind of unforeseen vulnerability,
Right.
you're more likely to deny access than accidentally grant it.
So it's like a built-in safety net, preventing any accidental or unauthorized access.
Yeah, exactly. Think about like forceful browsing.
Okay.
So that's where an attacker tries to access hidden parts of your application by just messing with the URLs.
Right, right.
A system that uses default deny would block those attempts unless the attacker had proper credentials.
So even if they stumble upon some hidden URL, they can't actually access anything unless they're authorized to be there.
Exactly.
Okay, so how would we implement default deny in a, real-world Java application?
Well, you want to start with secure configuration settings. A lot of frameworks let you set default access policies.
Okay.
And when you're designing your authorization mechanisms, the systems that determine who can do what
Right.
always start with a default deny rule and then explicitly grant access as needed.
Okay, so it's all about assuming denial first and then only granting access when it's absolutely necessary.
Yeah, that's the way to go.
All right, we've covered least privilege and default deny, which are all about preventing unauthorized access. But, sometimes things just go wrong. What happens then? What's the next secure by default principle?
Well, that's where our final secure by default principle comes in, which is fail securely.
Okay.
And this one is about handling errors and failures in a way that ensures the system stays secure.
So even in the face of failure, we need to maintain a strong security posture.
Yeah, absolutely. Imagine like you've built this super secure fortress,
Okay.
but somehow a battering ram manages to like bust open a gate.
Oh.
What happens next? Ideally, the rest of the fortress should still be secure.
Right.
The defenders can contain that breach and prevent any further damage.
Right. Yeah.
So that's what fail securely is all about. It's about containing those breaches, preventing them from cascading into bigger problems, and getting the system back to a safe state.
So how do we implement fail securely in a Java application?
The key is really robust exception handling. So avoid those generic exception handlers that just catch everything without any discrimination. You want to use specific exception types to handle different errors in the appropriate way. And that allows you to provide more helpful error messages and prevent leaking any sensitive information to attackers.
Yeah. So it's not just about catching every possible error. It's about being smart and deliberate about how we deal with each type of error.
Yeah, exactly. Think about it like this. Imagine your application encounters an error while it's processing some sensitive data, right?
Okay.
If you have a poorly handled exception, it could accidentally reveal that data in an error message, and that creates a security risk.
Oh, yeah, I see.
But with proper exception handling, you can log the error discreetly and just display a generic error message to the user.
Okay.
So you prevent that information leakage.
Okay, so fail securely is all about thinking about what happens when things go wrong.
Yeah.
And making sure our code is ready to handle those situations in a secure way.
Exactly.
Can we do a quick recap of the secure by default principles?
Okay, sure. So first we had use least privilege. That means grant users and programs the absolute minimum privileges they need to do their work.
Okay.
Then use default deny. You assume that access is denied unless it's specifically granted.
Okay.
And finally, fail securely. Handle those failures gracefully so they don't turn into security vulnerabilities.
All right, those are some really great points. Now, we've talked about designing secure systems, setting up secure defaults. What else is there?
Well, next we need to think about communication. How do our systems communicate with other systems securely?
Okay, so we're going beyond the walls of our fortress now, right?
Yeah, exactly. We need to make sure the messages we send between fortresses are protected. That's where secure by communication comes in.
All right. I'm ready to hear more about that.
Yeah.
All right, so we've talked about designing with security in mind, like secure by design.
Right.
We talked about setting up secure defaults with secure by default. And we even touched on securing communication between systems with that secure by communication principle.
Yeah.
So now I guess it's time to roll up our sleeves and dig into the actual code.
Right.
What's this last section called secure by implementation all about?
So secure by implementation is all about putting those security principles into practice.
Okay.
We talked about the high-level stuff, but now we're going to talk about the actual coding techniques and the best practices that you can use to make your Java code secure.
Okay, so we're moving from the theory to the practice.
Yeah, exactly.
Okay.
It's like, you have the blueprints for your secure fortress,
Right.
but now you got to pick the right materials, you got to use the right construction methods to actually build the thing.
Makes sense.
Yeah.
All right, so where do we start with this?
Well, one thing we should talk about is input validation.
Okay.
We've mentioned this in other sections,
Yeah.
but there are some specific techniques in Java that are really effective
Okay.
at preventing vulnerabilities, like injection attacks.
Okay, so input validation, it's all about treating every piece of data that comes into our application
Right.
like it could be dangerous,
So
right?
exactly. You should never trust user input.
Right.
You always got to validate it before you use it.
Yeah.
Okay. And one technique that's really powerful in Java is using prepared statements.
Okay, prepared statements, I've heard of those. How do they work?
So imagine you're working with databases, which is, pretty common in Java.
Right. Yeah.
A lot of times people construct SQL queries by like concatenating strings together, just sticking them together.
Yeah.
And that can leave you wide open to SQL injection attacks.
Oh, right.
But with prepared statements, you basically precompile the query
Okay.
with placeholders for the input values.
So it's kind of like a template for the query, and the input values just get slotted in.
Yeah, exactly. And the database sees those input values as just data, not code.
Okay, that's a good distinction.
So even if an attacker tries to inject some malicious SQL code,
Right.
it won't get executed.
That's really smart. It's like having a security guard right at the database door, carefully checking everyone who tries to get in.
That's a good way to think about it, yeah.
So prepared statements help secure those database interactions. What else do we have in our Java security toolkit?
Another important technique is output encoding.
Okay.
So even if you validated all your inputs,
Right.
there's always a chance that something might slip through the cracks.
Okay.
So you need a last line of defense, and that's where output encoding comes in.
Output encoding. All right, so this is like a final security check before we display any data or send it somewhere else.
Yeah, exactly. What output encoding does is it converts special characters,
Oh.
like those angle brackets and quotes, symbols.
Yeah.
It converts them into these HTML entity equivalents,
Okay.
and that prevents those characters from being interpreted as executable code.
So even if there's some bad stuff in the data, encoding makes it harmless.
Exactly. It neutralizes the threat, but it doesn't actually change the intended meaning of the data.
Right, right.
And a lot of Java frameworks and libraries actually have built-in support for output encoding.
Oh, that's convenient.
Yeah, so it's pretty easy to implement.
All right, so we've got prepared statements for databases, output encoding for, sanitizing the data before it's displayed. What else should we be thinking about when we're writing secure Java code?
Okay, let's talk about logging.
Logging. Okay.
Logs are really important for monitoring what's going on in your system.
Yeah. You need to be able to see what's happening.
Yeah, for debugging problems
Okay.
and for investigating security incidents.
Okay.
But if those logs aren't handled securely, they can become a goldmine for attackers.
Yeah. They could leak a lot of sensitive information.
Exactly. So the main thing to remember is don't log sensitive stuff.
Okay.
Like passwords or encryption keys or personal information about your users.
Right.
If you absolutely have to log that kind of data, you should look into masking it or redacting it.
Yeah.
Just hide those sensitive parts.
Right. Yeah.
And remember, the logs themselves need to be protected too.
Okay.
Make sure they're stored securely, they're transmitted over encrypted connections,
Right.
and only authorized people can access them.
So we need to protect those logs like the crown jewels. Right. What else? What other best practices should we be keeping in mind?
Okay, exception handling is really important.
Oh, yeah. Exception.
Not just for security, but for the overall stability of your application.
All right.
When exceptions are caught and handled correctly, you prevent those errors from turning into vulnerabilities.
Right. So it's like damage control.
Yeah, exactly. You got to make sure that if one part of the system fails, it doesn't bring the whole thing crashing down.
Right.
So again, avoid those generic exception handlers.
Yeah.
You want to use specific exception types to handle each error appropriately.
Be specific. I got it.
Yeah, and that way you can give better error messages to your users.
Right.
And you can prevent leaking sensitive information to attackers.
Okay. And it also helps ensure that the system fails gracefully, right?
Yeah, exactly.
Okay. So be specific and deliberate about how we handle errors. Any other Java-specific tips we should know about?
Yeah, one of the best tips is actually don't reinvent the wheel.
I love that tip.
The Java ecosystem has a ton of security frameworks and libraries that provide pre-built solutions for authentication, authorization, encryption, all that stuff.
Okay, so it's like having a team of security experts who've already built the most secure components for us.
Yeah, exactly. Using these frameworks saves you a ton of time and effort.
Yeah.
And you get to benefit from all that expert knowledge, and
Yeah.
they're using code that's already been battle tested.
Okay, so we should leverage those existing security tools whenever possible.
Sure.
Makes sense. Any other final words of wisdom for our listeners as we wrap up this deep dive?
I would say remember that secure coding is a continuous process.
Right.
It's not a one-time thing.
Yeah.
You got to stay up to date on the latest security best practices, use code analysis tools to help you find potential vulnerabilities.
Okay.
And, don't be afraid to reach out to security experts if you need help.
All right, well, this has been an amazing deep dive into secure coding principles and techniques for Java.
Yeah.
I feel like I've learned so much.
I hope so.
I'm definitely going to be using all this knowledge in my future projects.
That's great.
So thank you so much for sharing your expertise with us today.
You're very welcome. It was my pleasure.
And to our listeners out there, security is a journey, not a destination.
That's right.
So stay curious, stay vigilant, and keep those applications secure. We'll be back with more deep dives in the future.
Sounds good.